This is Mikhail. In this video, I'd like to talk about the architecture and implementation of how reverse gRPC tunnel works between the GitLab Kubernetes Agent and GitLab Kubernetes Agent server. So in this diagram, that's that part. CAS gets a request and uses an existing tunnel to the right agent pod to send the request. So here is more detailed more specific high-level overview of the implementation, basically. So what we have here is, this is CAS, this is agent. The idea is that when CAS starts, the modules that expose some functionality register some API, gRPC endpoints on an internal gRPC server and or on the public API gRPC server. So the public API server is the one that can be accessed by GitLab. The example that this document uses is to get a list of pods in some agent. And the internal one is used for something else. And an example here is a Kubernetes API proxy. So we do not want to expose this API server, the internal one. Instead, we will expose an HTTP server, and that's how we will get the traffic into the server, into CAS. So the idea is we expose some API, and then the requests that come to CAS should be proxied to the internal gRPC server in the agent, and then that server dispatches the incoming request to the corresponding agent module that is responsible for, the agent side of the functionality. So if we are talking about getting a list of pods, then it would be this module that would get the list of pods. So this is the more interesting implementation scheme of the diagram above. So this part is the same. We register some APIs. Then for the incoming requests, we use the connection registry to delegate the handling of the incoming request to it. And by handling, we mean proxying the requests to the right agent via an incoming tunnel. So here is the server side of the tunnel module, which accepts the incoming tunnel requests, and then it also gives them to the connection registry. So the job of the registry is to match incoming requests with incoming tunnels, basically, and proxy the traffic in both directions. So if there is no matching tunnel, then the incoming connection sits there and waits until the tunnel is registered, and vice versa. If there is a tunnel, but then there is no incoming request, and the tunnel sits open and waits. So both incoming connections do not sit there forever, of course. They can be interrupted either by the client, either an external party making the request to one of the gRPC servers, or the tunnel. It just has a max connection age, so it will close the connection and reestablish it. So, and the job of the counterpart of the server tunnel model, the agent tunnel model, is to, once it starts getting some traffic in response to the established tunnel, its job is to proxy this traffic to the internal gRPC server of the agent, which is not exposed to any network. It's in memory only. And that's on that server we have this. We have the modules that handle some requests like list pods or access Kubernetes API. So this is the high-level kind of overview of how this works. And we can look at the scheme, at the code as well. So let's start with the tunnel, the reverse tunnel modules. So both agent and server modules use the connection registry, as we saw here. So this server, sorry, the server tunnel module uses the connection registry, and the servers, like the modules, use the connection registry. The agent does not, but they both use the API, the gRPC API definitions. So let's look at that first. So here is our service. So the agent calls this method and it connects to the server. That's this request. And it sends a connect request. So the first thing it sends is the descriptor of the agent. And it's currently empty, but the idea is that it will send the list of methods, API methods that it supports. So agent K can be of different versions in different pods running in the same cluster as the same agent. So if we introduce a new API, we want to be able to send the request to the agent, to the pod that already supports this API if an upgrade is in progress. So here we will list the supported methods of this particular pod, basically, when it establishes the connection. And then it sits there and waits for a response. And response is the request method and metadata. So the request and response are inverted here, as you can see, because it's a reverse proxy tunnel. So we send information about the agent itself. Then the server sends us a request that it wants to make to our internal API server of the agent. This is the name of the method and the metadata. And then the server and the agent start bidirectional streaming. So server starts sending messages, so body of request, one or multiple messages, and then eventually it closes the connection, closes the send side of the connection, and the server, the client sends as part of the connect request, it sends the headers, the response headers of the internal gRPC server. So what this server replies with here, we send the headers, the message, and the trailers. And well, messages are just binary blobs, and trailers and headers are just metadata. So this is the definition of the protocol, basically. So it's quite simple, I would say, nothing fancy. Then let's look at the, no, it starts with the agent. Let's look at the agent. So that's the factory, it constructs the module. We establish 10 connection, 10 tunnel connections, because why not? It should be more sophisticated. It should keep a bunch of idle connections to ensure that there is a way to make a request to a module, but it shouldn't be a fixed number, and it should be a limit as well, of course. So we have a connection to CAS, and we create a client to make this particular type of requests, reverse tunnel client. And then that's it, basically. So what the module does is it just establishes end connections at the moment, and it waits for them to stop, and they stop when the context is cancelled. So this is the connection that it establishes. So it just keeps retrying with some delay to establish a tunnel, and then if there is a successful, if the request has been successfully processed, then it will reestablish it again, or if it needs to stop, it stops. So each attempt is basically, so because it's a bidirectional streaming proxy, we have two Go routines, one which streams from agent K to CAS, and the other one which streams in the opposite direction. So here is where we are making the outbound request, and we send the descriptor about the agent. So this is the outbound request to establish the tunnel, basically. And then we start reading the response using the stream visitor. So first we receive the request info. Then this is the request info that we receive. And here is the server is telling us which API it wants us to call. And that's what we do here. We have the connection to the internal API server. So to this internal API server. That's what we do here. Create a stream with this method that we need to call, and the metadata that we got from the request. So both the method and the metadata, we got them from the request. Well, from the response from the server. And we establish the stream, and then we tell the other Go routine to start consuming that responses from that stream, so that we can send them back. Then here, basically, this is unblocked and it starts working. So then we proxy in one direction and close the connection once we have proxied all the messages, and then we proxy the opposite direction. First, we respond with headers, then we respond with a stream of frames, so the stream of messages, and then we respond with trailers, and then we also close the response stream, the tunnel. This is how this part works. Okay, let's look at the server part. So the server module and how it uses the connection registry. And they live here in a sibling directory. And we also have a factory which it registers the endpoint. So for this module to make a request, it registers an endpoint on the, it's actually, we have another gRPC server here. It's an API server for all the agents to connect to, and that's what receives the request, basically. So, and as a handler of that request, we use the module itself. So factory constructs the module, registers the module with the gRPC server, and this is the method on the module that will be handling the incoming tunnel. So here we perform authorization. We ask GitLab for information about this agent. If there is an error, we return. So no such agent or invalid token or missing token or anything like that. And then this is where we delegate to the connection registry to handle the incoming tunnel connection. So this part, handle tunnel connection, it's the method. And this blocks until either the context on the server times out, or there is an error processing the connection, the incoming connection, or there is an error reading from the tunnel, or the service is shutting down, or anything like that. And we return the error to unblock the gRPC server. And this is that part basically. And to demonstrate one of these, we can either look at a test, or it would be more interesting actually to look at a draft reverse Kubernetes API proxy branch. So there is this new directory, Kubernetes API, and we have a server and the agent. So let's look at how the agent works first. So basically, we construct the REST transport for the Kubernetes API, and that's what we use to make requests from the module, and we register the module using that internal API server here. And that's the make request. So I should probably show this first. This is the Kubernetes API make request and receive response, a stream and a stream, because request and response may be of arbitrary size. So it's usual HTTP stuff, headers, status, response, body and status code and trailers and all the usual stuff. So this is the server, this is the agent module, sorry, and it also does the bidirectional pipe in this direction, pipe in the other direction. And the server, this is what I wanted to show. This is the factory of the server side. So one of these modules, it's an internal. We use here we use the internal gRPC server. So this is the reverse tunnel server. It's the internal gRPC server. And here we construct a gRPC client for the Kubernetes API, which uses the internal connection to this gRPC server. And the module itself is the handler for the incoming requests. And let's look at the module. So this is what it does. So it doesn't do authentication, authorization, anything at the moment. And also it's hard coded to number 4, which is my local agent ID with my JDK. But it's to show how it will work. So after all the checks are done, and after we have determined the agent ID from the incoming request, like from the deployment token, for example, we use it here, and we give the connection registry the incoming connection, basically. This is that part. So one last thing is connection registry. So here we have something interesting. So one Go routine executes the run method, which is the Go routine that dispatches between incoming tunnels and incoming connections to match them. And we have 2 methods for handling incoming connection, for handling tunnel connections. So this is basically the core of the logic that connects them together. Yep, you can have a look at how it works. Yeah, this is basically it. registering connections in memory, and then matching them once incoming tunnel and incoming connection came. Okay, I guess this is it. Thank you for the attention.